All right, today we got a 428 FE on deck. Stay with us and we'll get into it. All right, so this thing, and here we go again. So this thing was at another shop. It has had some work done to it. It was supposed to be ready to assemble, and I don't exactly remember the whole story, but I think somebody got cold feet. They didn't feel good about the work. I don't know. But anyway, it ended up here. All the parts are new in a box, and the block has been bored and honed, and a set of cam bearings. No other work's been done, and it's supposed to be ready to assemble. So upon initial inspection, we noticed that the bores were just all over the place. They're all over the place, and they're too big. They're too big, and they're all over the place. So, we looked it over, and on these FEs, and a lot of stuff is like this. It ain't just a FE, and this is a 428. It's a little better than like a 390 or a 360, any of that stuff, because they're like super duper thin. These are not quite as thin as the 390s are. But you got to line hone every one of these things. You got to deck them, because the problem is, especially with these, because I've done a lot of these things, and the deck is never parallel with the crankshaft. It's all over the place. I mean, I've seen some, Lord have mercy, like the deck will be out 10 or 15 from the crankshaft center line. Now, not all of them, but I've seen some that bad. So and depending on what kind of boring table you got, but most people's boring tables reference from the deck. So when you bore the block from the deck, with a crooked deck, you got a crooked cylinder, and that's just how it is. We had one coming here. It was supposed to have been a 428, but it was actually a 390. Somebody had bored it to a 428, and we chucked up on it and indicated it in, and they had bored it crooked to the deck wasn't that crooked. I don't know, they'd had a setup problem. I don't know what they had, but the cylinder was crooked to the deck. It wasn't perpendicular to the deck. So we just did a light bore through it, and down at the bottom on one side and at the top on the other side, it didn't touch anything because the cylinder was crooked. So I mean, they pretty much just ruined that block. But so what we've got is they have bought, so we got the block. I don't know where they got the block at, but they got a block. They bought a rotating assembly from somebody, and we've got an Eagle crank, 4 1/4 stroke. We're gonna talk about it being rusty in a minute. We got some Eagle, like I-beam cheap rods. We've got a set of complete Edelbrock heads. We're going to do a cam and lifters for it, and we've got, what did it do with the piston? Oh, hang loose. And the next problem is we got a Mala piston, great piston, no actual problem with the piston, but they bought a flat top piston. So we've got, so this is where, people that don't know, like they just don't understand what they're buying, or they buy stuff and they were going to use this head, but then they used this other head, and now things don't work out right. So this package together with this flat top piston and this cylinder head, which is 72 cc's, comes out roughly at 11.6 to 1. So that is probably not going to work. I mean, this thing is going to be a street cruiser. It's going to have like Sniper EFI or something, but I'm pretty sure it's going to be AC, automatic, and they want to drive it and be able to run pump gas without having the timing on 12, right? So it needs to be, and I don't want to have to put a cam in it with a really late intake closing to try to bleed off the compression and make it a turd. So we want to run like a nice little mild street cam and have the compression where it should be, so we can keep the dynamic, you know, down there at 8.5 or whatever, so it'll run on 93 and not be an issue. So with the cylinder issue, and we're gonna look at that in a minute, but with the cylinder issue, unfortunately, probably the only way we're gonna fix it, and we can't straighten the cylinders because we just can't now. But what we can do is these, and I'm gonna touch on this, and we're gonna do another whole video about torque plates all by itself just soon, because I keep getting them comments, so we're gonna nail this thing down. But these blocks, because if you look, you got 1/2-inch head bolts, and we just got 4, and they're concentrated right here, and it really draws the cylinder when you torque these. I mean, they torque to 100 pounds. So it distorts the cylinder really bad. And, you know, some people don't use torque plates, some people do use torque plates, some people think you got to use torque plate on every motor you do, and some people think you don't need to use torque plate on anything. And this is one of those engines that you better use a torque plate, because it's going to move the top of that cylinder. I guarantee you it'll move it a thousandths. But other things move the cylinder around too, and we're going to get to that. But this one, I feel confident, did not get a torque plate. I don't see any evidence of a torque plate. And like I say, it hasn't been line honed, it hasn't been decked. I mean, all the other boxes hadn't been checked, so why in the world would we use a torque plate if we didn't do any of the other processes that you should have done? So we're going to go from 30 to 40. And we're going to have to buy another piston, because that piston won't work. It's already got too much clearance in the block now, and the piston needs a dish, a small dish, but it needs a dish. And we CC the heads of pistons all the time, but this sucker is paper thin. I mean, I didn't measure it, but it's thin, and I just don't think there's enough material for me to machine a dish in it for us to get there. If there was, but we still got the bore problem, so that still doesn't fix the issue. But hopefully, you know, we can either sell them for him, or I don't think, it's been so long now, I'm sure he can't send them back, so he's stuck with that piston. So let's just look at a couple of cylinders. So I got this thing set up. The piston is 30 over. They're calling for 4 and 1/60 finished bore size. I think that gives that piston 4 thousandths clearance, because it is a 4032 and not a 2618, which is great, because a 4032 generally takes less clearance, and it doesn't, you know, it just doesn't have as much thermal expansion. So that one right there is dead zero, you know, in that plane at the top. And down at the bottom is 0. Let's see if we can turn it this way. And it's, how much is that? I can't see it. Yep, about a half. Yeah. That's pretty good right there. All right, and then this one, I mean, right beside it in the exact same location, it's about 2 2/10 too big. In the middle, we 1.5 thousandths too big, and then all the way at the bottom, we are, good Lord have mercy, another 2.5 too big. So we back to 0, 0, 1 in the middle, too small. Oh, I gotta turn it this way. So whatever that says, I can't see it. And then we're back pretty close to 0 there. And then 0 again. It's crazy how they got it. I mean, they hit it on a few of them, and then some of them is just like, you know, Ray Charles again. And I mean, you know, like when you got one like this, I mean, you know, you can't put that metal back. I mean, it's just gone. I mean, look at that. I mean, that's just like that's 3 thousandths. I mean, 3 thousandths too big. So you know, the piston wants 3.5, and you got 3 extra. I mean, that's 100% too much clearance. And you know, at bottom dead center and the top dead center, when it changes directions at the dwell, it rocks the piston. You know, and that's what makes noisy. Like it'll actually audibly make noise, like a knocking sound when it changes direction, and or it'll just beat the skirt off, right? You know, when that thing, it can't. You know, that's the whole purpose of clearance. We can't just slap it around. You know, like I do Andrew when he don't mind. All right, so that's about that's 1 right there. So that's 1,000ths too big. About 6/10 too big, and that's 2 thousandths too big. So you get the idea, right? It's just all over the place. It not only is it wrong, it ain't even consistent. It's just a mess. All right, so that's what we're dealing with there. So we there is no fixing that. We're gonna have to go 40. And I sonic tested a cylinder, and you can tell. I'll do one right quick. You can tell right off. Like if you know, people claim I got a 428, but they really got a 390. All them old 390s and 360s and all that junk, most of them suckers is the cylinder wall thickness is well under 200 thousandths. I mean, I've seen some like 140, 150. Standard bore 140, 150, so imagine what it is 30, 40, 60 over, you know. So, and that's why with these FEs, man, we sonic every one of these suckers, because you just don't know. I mean, till you check it, you don't know. And if it's paper thin, it's gonna be problems, and we're gonna talk about that in the torque plate video. All right, well, I guess it helps if I turn it on. That's always a plus. All right, so that's this wall about not quite middle ways. So that's what the wall thickness is. All right, so straight down between 2 cylinders, we just lost almost 50 thousandths of wall thickness. And then I'm gonna go straight up on the other side. And so we back up to 200. And I feel like anything, by 3/16 is on performance stuff, I wanna see 3/16. But more important than seeing 3/16, and then we're back to 2, you know. So the thrust walls are relatively thick, and then the front to back walls are a little thinner. And that's what we see in a lot of stuff. But this is good. Like I say, if this was a FE, I mean, most of the FE, like the 390s I've checked, you know, you'll barely see, a thick spot will be like 170. And we've seen some as thin as 90, and it's amazing to me that it even works. But it does, but it's amazing to me that works, that you can ride around with a 90,000 cylinder wall. But you can, but I mean, I wouldn't be hot rodding on it. All right, so that's the block disaster. So we got to fix all that mess, and you know, there's just, it is what it is. All right, so back to the crank. You know, whoever had it, they left it out of the bag, and it was just stuck in the box, so it's got rust all over it. Luckily, you know, we got a stainless tank that we would evapor rust in it that we can put this stuff in, and it works really good, and that's not terrible. And it's not really on the journals, it's just on the counterweight, so it's nothing really bad, but it is an Eagle crank, and I just absolutely would rather not use Eagle stuff. If you come over here and look, I don't know if you can see it. Can you see that texture in the camera?
A little bit, yeah.
So they knurl, and again, it's to hold oil, but this is where the rear seal sits. And they run a knurl pattern on this area to hold oil, to lubricate the seal. The problem is it's way too wide and it's way too deep. So what happens is, and I hear this story all the time, people put these cranks in, because basically this is just a cast steel replacement 428 crankshaft. That's basically all it is. But you can't keep a rear seal from leaking because it's so coarse. And what most people have to do is they'll have to send it to a crank grinder or somebody, you know, and they got a little narrow wheel, and they go in there and just touch that up and knock, you know, 5 or 6 thousandths off the diameter and make the knurl not nearly as deep. And then you can keep a seal in it. But, because, you know, you got about, I don't know, most of them rear seals, I think the diameter limit's about 15 thousandths. So you could go 15 under on that diameter and the seal would still be fine. And I may be off a little bit, but I think it's somewhere right in that window. So that's an issue that, you know, I don't know, we got to deal with, because, you know, who wants to put a motor together and then, you know, customer calls and my rear seal's bleeding to death, and, you know, what do you do now, right? But again, this is, you know, customer supply parts. We got to work with what we got, right? So the cylinder heads, I don't ever buy a cylinder head complete. I just buy them bare, and we just do all the work here, valve job, and set up the springs and the tip heights and all of that junk. Surprisingly, now I ain't checked them all, but I've done a bunch of Edelbrock heads in the past, and the valve jobs were just always garbage, just absolute garbage. Now this one is not good, but the runout is good, and I was really impressed because most of the time the valve seat runout is just absolutely horrible. Where did I do with my pilot? So a couple of things. I mean, the head looks really good. It definitely needs, like, the short turns are just garbage. The short turns need some work, but that's all heads. I mean, almost all heads, the short turn, and there's just so much there. I mean, 15 minutes in the throat and the short turn is worth more than 2 hours everywhere else. I said what I said. So, let's see. Let me get zeroed here. So that seat has got no more than a thousandths and a half run out, which is really good. I mean, I've seen some back in the day that were, shoot, they had 10 thousandths run out. I didn't check the exhaust, but I mean, we're gonna touch all this stuff anyway. But what I did do is I just cleaned everything up, and I just put some Dykem on the valves. And this, I hope you can see how far back the 45 sits on that valve. I mean, I run my 45 slam out there just almost to the edge. You know, some people may argue about that, but, you know, you just have to show me that that's not better. But that is no good. That's no bueno. I mean, it's way up. And there ain't no width to it, right? You see how much width you got. And this is where, this contact area is what pulls all the heat out of this valve and puts it in the cylinder head. Well, and the guide too. But you need some width. I mean, you got to have it, or it's just going to, the head of the valve is going to be hot, the seat's going to be hot, and it's just not friendly. All right, so that's the exhaust, which is the one that, if one was going to be right, it should be the exhaust. So this is the intake. It's the same way, and you can see how thin the line is, and that's telling me that the angle on the seat and the angle on the valve are not the same. And you know, there's this old wives' tale. You know, I heard it when I was a kid. You know, oh, you need a 45 on the seat and a 44 and a half on the valve, or vice versa, some nonsense. Both angles need to be the same. I don't care what nobody says, both angles need to be the same. And if you make both angles the same when you lap it or do whatever you use Dicom or, I use like 2000 grit lapping compound. It just, you can really see it, and it's so fine that it's not cutting anything. It just gives me a nice pattern. And the Dicom works, but it is what it is. But you can see that if you got both angles the same, you can see the ceiling width, right? But if you have two different angles, you're just going to see a little old sharp line like that, which is garbage. And people you say, oh, it's going to wear in. Well, man, if you wearing the seat a half a degree, like that's a problem. I mean, that's like a real issue. So that's another deal that we'll correct all that, because the seats need to be opened up. And I didn't check the tip heights, but we'll adjust all of that stuff. And it's got a set of Harlan Sharp rollers. And so they're on stands, so we can adjust the rocker height and get the tip profile happy, and the pattern and the sweep and all of that. So, but overall, it's a good head, and for the money, what you spend on those factory heads just trying to fix them. One other thing, I don't know if you can see, get over here in the light a little bit. Can you see that pattern? How rough that is? So let's just check it with the profilometer. So we did some the other day here on our surfacer, and we checked them, and they were like, we average like 11 to 14. That's about the RA we see on most stuff. $54. So, I mean, that is super coarse. I mean, my old 1950 Van Norman brooch would make in the 40s. If I was really on top of it, I've seen some aluminum under 40. So, like, how they sending that out that coarse, I have no idea, because with a MLS gasket, that right there will bleed. It'll actually drip in between the water jackets. I've seen it happen, especially like foreign cars and stuff. If you don't get the surface finish fine enough, it'll weep. The MLS gasket will weep because the texture is so coarse. So I think we'll just make this like the introductory video on this job, and like I say, we got to get a piston. I haven't even found a piston. This job was supposed to be started in December, and several of these other jobs, the small block Ford, they were all scheduled for December, and we're just that far behind. So, I ain't found no pistons for it yet, but I'm on, and we may even have to have one made. But luckily, we direct with most all of the piston companies. And the bad thing is now, I mean, I think that set of pistons, I think they give almost $800 for them. And I mean, we have custom pistons made to our spec for about the same money. So it's really no savings. I mean, we can have a piston built and just do whatever we want to do. I mean, we can make the head whatever CC, we can make the pin height whatever. So, once we measure, because somebody like these and some other stuff too, I mean, Buicks and some of the Oldsmobiles, they just weigh 440 Mopars, they like that. The deck is really tall, so the pistons way in the hole. So either you got to cut a pile off the deck, or you use something else, right? So once we kind of mock up and figure out where we at, do some measuring, we can make the piston a little taller if we need to, so we don't have to take so much off the deck. Because with these things, and some people, I'm gonna just flip it over so you, because some people may know and some people may not know, on the FEs, the intake actually sets on and becomes part of the valve cover rail. So they're just horrible for fitment anyway. And then the heads are also a train wreck most of the time, because usually we have to cut this surface, we have to cut the intake flanges to get all of that stuff to line up, because it almost never lines up. I mean, almost every one I've ever done, we had to cut the intake side, we had to cut the intake, and some of it stems from having to cut the deck so much because the decks are always so bad. And then the new intakes are just too wide, or they're not flat. And this surface, like I can see, you can just look at it, the texture's horrible, and you can almost see waves in it. So I'll guarantee you this surface is not flat. So we'll have to cut all of this stuff and get it flat and happy. And it's a lot of work, and it's a lot of extra money. But if you want this junk to live and seal and not give you problems down the road, it's just what you got to do, unfortunately. So that's the story. We're going to get some pistons into works, and as soon as we get a piston in here, I think we're going to go ahead and get it line honed and get it decked and see where we end up on deck height. And then we'll know what wrist pin height to actually order to make it all work out right, because we don't want the piston 30 in the hole. I mean, I don't mind 10 or something, but I don't want it way in the hole, and I don't want it sticking out of the hole either. So, all right, stay with us, and we get some more pieces in here, we'll bring you back. Thanks so much. Like, share, subscribe. Check out the website if you need anything.